Hello, and welcome to 5 Minute Math. Today we are looking at the sixth grade concept of triangle. Specifically, what are some different properties of triangles that we need to learn about, and we'll do it in 5 minutes or less. So triangles are pretty basic, three-sided polygons, but there are some interesting properties of triangles that we need to remember. This first one has a name. It's called the triangle inequality theorem. What it says is that if you add any two side lengths of a triangle, so I'm just going to kind of draw one for our reference here, the sum of any two side lengths is going to be greater than the third side length. So let's call this a side y, side x, let's put a side z. Okay, so what this says, if I add x and y, that has to be greater than z. If I add x and z, that has to be greater than y. And if I add y and z, that has to be greater than x. And if all of those three inequalities, that's why it's called the triangle inequality theorem, are correct, that means it is a triangle, as long as the sides are connected at the endpoints. So let's get some numbers for an example, right? So this might be 5, and this might be 3. So let's say these units are 5 and 3. Usually when we're checking the side lengths of triangles, it's always best to just look at the two smallest sides, add those up and make sure they're going to be greater than the longest side. So this right here, this z, it has to be less than 8. If it's 7.9 or less, we're good to go. But if I were to call z 8, then that would not work because 5 and 3 equals 8. It needs to be greater than 8. So I'm going to call this 7. Right, just for our example purposes here, we're not trying to find the exact length with the Pythagorean theorem. This could be a triangle, because what this means is 5 plus 3 is greater than 7. That works. We can say 5 plus 7 is greater than 3, definitely. And then we could also say 3 plus 7 is greater than 5. So all three of those work, which means this is a triangle. The nice thing is you can do this without any picture. You can just get three numbers and be asked, is this a triangle? So let's try this. Let's say we've got a 3, we've got a 4, and we've got a 9. Those are our three side lengths. Could this be a triangle? Well, hopefully you're already saying, you know what, 3 plus 4 does not equal something that's greater than 9. It's actually less than 9, which means this is untrue, which means that this cannot be a triangle, because that 3 plus 4 needs to be greater than that third side length. That's the triangle inequality theorem. Something else we know about triangles is called the angle-side relationship. That just simply says the largest angle of a triangle is always going to be opposite the longest side. The smallest angle of a triangle is always going to be opposite the shortest side. So let's see how that works. I'm going to draw an obtuse triangle here. And we can just see, without even measuring this, right, we can see that this right here, this obtuse angle, is my largest angle. So I'm going to just kind of estimate that. We're going to call that 120 degrees. What this angle-side relationship property tells us is that the largest angle is always opposite the longest side. So think, what is opposite? It's going to be this long side right here. So this is going to be my longest side. So those are always opposite each other. Now, if we look at these other two angles, they're pretty similar, but this one right here is I'm going to draw a little tiny thing right there, put a little slash through there. That is actually my shortest angle, or my smallest angle. And we know that there's only 180 degrees in a triangle, so if there's 120 already in that one angle, there's only 60 left. Only 60 degrees left, because all triangles make 180 degrees. So I might call this 20 degrees right here. That's my smallest angle, and that's going to be opposite my smallest side right here. And then this would probably need to be 40 degrees, and the middle one is across the middle one. But that is angle-side relationship.